Hey guys, we're going to take a look today at another kind of factoring. When I concluded the last lesson on factoring, I had looked at a problem like x squared minus 4. And we said if we were looking for the greatest common factor for that problem right there, we would not find the greatest common factor. And yet there was a way to factor it, and we would be looking at that next. So let's look at it now. What I want you to notice right now is that this term, there are two terms here. First of all, it is a binomial, meaning that there are two terms. The first term is x squared and the second term is 4. And each one of those terms is a square. As you read it, it says x squared. This is 4, which is 2 squared, as you know. And this is a minus sign, so it's called the difference. So you see up here I've written difference, meaning minus, find the difference in two numbers, subtract. So this is all about minus, always. And it's all about squares. So first of all, let's quickly just kind of list out a few squares just to kind of get you thinking in that mode. And so you know if 2 squared is 4, then 3 squared is 9, and 4 squared, say it with me, yes, and 5 squared, yes, and 6 squared, 36, good, 7 squared, 49, 8 squared, 64, and so forth, okay? We also know we certainly have x squared, y squared, a squared, any other variable letter that we choose that we might see could be squared. But watch this, as long as you've got an exponent that is an even exponent, it is considered to be a square. So x to the 4th, and you know this from our study of exponents, x to the 4th is x squared times x squared. So x to the 4th is considered a square, not surprisingly. But x to the 6th is surprisingly a square for some people. X to the 6th is x to the 3rd times x to the 3rd, because you know you add exponents when you multiply. So x to the 3rd times x to the 3rd is x to the 6th. So then x to the 6th is the square of x to the 3rd. And that's a lot of tongue twisting in words, which you'll see in just a moment. Okay, let's take one that is like this one, and we look at it and we say, well, we do not have a greatest common factor, because that is definitely what we would be looking for first, but there is not one. So we move to the second type of factoring called difference of two squares. We're like, well, is this a difference? Yes, it is. It's a minus. That's all it means. Is each one of these a square? Are these two squares? Well, yes, that's a square and that's a square. Well, then if so, the factorization of that is always like this. You have two parentheses, and one of them's going to be a positive and one of them's going to be a negative every time. And then you say, well, how would I get x squared? What times what would give me x squared? Or another way to say it would be, what is the square root of x squared? And hopefully you're saying, well, it would be x. And if you're not and you're lost, just hold on a minute, because remember from exponents, you might need to go back and review the section on the meaning of exponents. But x times x is x squared. So that is the truth. X times x is x squared, and so that works. That's the truth. We're like, well, what times what is 4? Well, we know that. It's got to be the same number now. The square root of 4 is 2. So we're like, okay, 2 times 2 is 4. And so this is the way that we factor x squared minus 4. Now we are going to check it, but I want to factor a few more to kind of get in the rhythm of it before we start going back to check them. So let's just stay with this pattern just a minute, and you see the pattern. Let's say we've got x squared minus 9. So going by the same pattern, we would have x plus, what times what is 9? 3, good. So we got x plus 3 and x minus 3, good. Okay, let's jump now and say we got x squared minus 100. Okay, I call this a little skeleton that I get started out here with. Is it a minus? Is it a difference? Yes. Is it a square minus a square? Yes. So take the square root of both, x times x, 10 times 10, and one is a positive and one is a negative. We'll see why in a moment or two when we check. All right, let's say we've got x squared minus y squared. Well, is it a minus? Is it a negative? Is it a difference? Yes. Are they both squares? Yes. Square root both of them, x plus y, x minus y. This is kind of a lot of people's favorite kind of factoring, because really once you see the pattern and once you catch on, it's very, very simple to do. It really is. So let me see, even if we got a fraction. So let's put a fraction in. Let's say we've got 1/4 x squared minus 9. We're like, well, is it a difference? Yes. Is everything a square? And yes, everything is a square, but maybe it takes you a little longer to get it that 1/4 is a square. So you say to yourself, is 1 a square? 1 times 1, yes. Is 4 a square? 2 times 2, yes. So 1/4 is a square. So here we go. It meets everything we need it to meet. So we go, well, if that's the case, what times what is 1? 1 times 1, so we do that. What times what is 4? 2, right? So I've got 2 times 2. So double check. 1 times 1 is 1. 2 times 2 is 4. That's good. Yay, yay. All right, x squared. And that would be x times x. It's a minus. Remember the pattern? Plus minus on all these. So we put plus, minus, square root of 9. Yeah, 3. So there we go. So it looks kind of messy with the fraction. It looks kind of scary, but this is one time it surely does not need to be a problem for you if there is a fraction that is a square. You just got to recognize that it is a square. Okay, watch something like this up here. Suppose you might have sometime negative x squared plus 25. And you look at that one and you're like, well, it is 2 terms. They are both squared, but I'm so used to seeing this negative in the middle that if it's not there, it's bothering me a lot and I'm not really sure. Well, in that case, let's just turn it around. Let's just say that I'm not taking something to the other side, so I'm not changing any signs or anything. I'm just saying that negative x squared plus 25 is exactly the same thing as 25 minus x squared. Because the 25 is still positive and the x squared is still negative, so it's all right to rearrange something like that if I want to. Because everything is still a square. And then there's still a negative in the middle. So I recognize as a square minus a square, or a difference of 2 squares. And so then I can say, what times what is 25? Well, that would be 5. There would be a plus and a minus, and then it would be x times x is x squared. Get it? So I show you that way so that you can recognize that you might have difference of squares even if the square isn't in the middle. Now, it's really customary, rather than to switch places, it's customary to lead off in standard form so that your leading off term is a positive. So remember, if you took the GCF track before this one, we said, let me just kind of separate that. If you have, it leads off with a negative and you wish it did not, you can always factor out a negative 1. So let's factor out negative 1 from here. And then we would have x squared minus 25. And again, as we said earlier, that's just manipulating it if you want it to be in that form. So if you do, then you say, okay, now I recognize a square minus a square, and x is first, and that's comfortable, and that's standard form, and that's great. So then I can just factor with my difference of 2 squares, x plus 5 and x minus 5. Okay? And at this point in time, in this level, these two answers may not look like they're exactly the same to you, but they are. So you've got really 2 choices, and some of this depends on your teacher and your book and so forth, but as far as the meaning of it goes, they're both correct. This one is favored here and usually used because it is better to stay in standard form with your original problem. Some people, though, occasionally you will see it done this way as well. So either one, whatever your teacher tells you to do is the way that you want to go about this. Okay? And so really, as far as a square minus a square, there is one more thing that I want to go over with you. So sit tight just a moment. And let's take a look at some where the exponent is greater than 2. So it's not maybe quite as obvious that it's a square. For instance, maybe you have x to the 4th minus y to the 6th. Okay, remember earlier we said if the exponent is even, it is a square. But 6 does not feel like a square. But in exponents it is. So let's look at that just a moment. But let's proceed as if we really understand that this is a square minus a square. This would be the only one that would be in doubt that we really have to look at. So we say, well, what times what gives me x to the 4th? X squared. That feels good. Negative, so I need a plus and a minus. It's the only way I'm going to get a negative when I multiply. Now here's the part. You got to know about the meaning of exponents and the laws of exponents previous to this. Y to the 6th, the way you get multiply and get y to the 6th is y to the 3rd times y to the 3rd. Because y to the 3rd times y to the 3rd is y to the 6th. When you multiply, you add exponents. So this relies on a previous knowledge of the laws of exponents. So if you're struggling with that, weak in that, you need to go back and get that under control before this is going to be really, really clear to you. You'll still see the pattern, and let's do another one. Suppose we have x to the, we'll just stick with 6 a minute, minus, let's say, let's just say 1. Okay? Do we have a square? Yes, we do. It's even. Minus a square. Is 1 a square? 1 times 1? Oh, yeah, it is. So here we go. Same thing. A plus and a minus, so we can kind of get used to that. The 1's easy because it's 1 times 1. We're like, okay, now what was it with the 6? X to the what times x to the what? Think, 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 or look back above. Yes, it's x to the 3rd times x to the 3rd, because when you multiply that, you get x to the 6th. X to the 6th, because you add exponents when you multiply. Okay? Here's one that I like to play with a little bit. I like to give students x to the 16th minus 1, because it's got so many steps and so many layers, and you really get it, I think, by the time you finish it. So you say, is that a negative? Is it a minus, a square minus a square? Is it an even exponent? Yes. So here we go with our factoring this. We know it's a positive and a negative. We know it's 1 times 1 is 1. But on the x to the 16th, we're like, well, what times what? Well, we know we got to add exponents. We know they have to match. They have to be the same, so we know it's x to the, 8th and x to the 8th. All right, that's great, because adding your exponents, x to the 16th, checks. All right, now, one of these is still the difference of 2 squares. Well, it's not that one, because that is a positive, so it's not a difference of 2 squares. This one, however, is. Okay? So, when we're getting ready to write our final answer, this is definitely right here in our answer, so I'm going to put it over here. X to the 8th plus 1, and it is not going to change. It is not. It's not a difference of 2 squares. It's not going to change. It's set in stone, so there it is. But this one is a difference of a square minus a square. So let's just focus right in here just a moment and say, okay, a square minus a square, then we get to break it down again. So, all right, half of 8 is 4, good. So we know we got x to the 4th and x to the 4th, because x to the 4th times x to the 4th, add them up, is x to the 8th. Yep. We got a plus and a minus, 1 and 1. Okay? Good with me? Okay, now we always have to look at our answer and see if it's possible to factor it again. And we're like, well, these two are not going to be difference of two squares because they're both positive. But this one is a difference of two squares again. So we hang on to these two that we've already got. We keep them, so let me write them down again. So we've got x to the 8th plus 1, part of our answer. X to the, whoops, not 8. X to the 4th plus 1, part of our answer. And now right here, this one goes again. We've got x squared plus 1 and x squared minus 1. And guess what? It'll go again because we have another square minus a square. So every time we get a square plus a square, we're finished with that part. We keep it. Keep it, keep it, keep it. So our final answer, even though I've written it down so many times, I've got x to the 8th plus 1. I've got x to the 4th plus 1. I'm just bringing this down. Now I've got to bring that one down. I've got x squared plus 1. Now, here's one that has a square minus a square again. So I have to go one more time with the square minus the square, and I have to go x plus 1 and x minus 1. And how do I know I'm done? How do I know I'm complete? I'm finished because I'm completely out of squares. My x, no more squares. Except here, but it's not a minus. Here it's not a minus, and here it's not a minus. So all of this is our answer to factoring x to the 16th minus 1. It's just a good practice one to get you to be able to really understand how to recognize exponents that are squares that don't look like they are. So try x to the 16th minus 1 again by yourself, without looking, and then look back and see if you can get this right. A lot of variations to this. We could do this all day, but this is the introductory to it. It's very basic, but I think it will help you to understand what we mean when we say we're going to factor something by the difference of two squares. Or sometimes a book or a teacher might say a square minus a square. So this is the second way that we have factored. We have had greatest common factor, and we have had a square minus a square. So we'll have another on the next download, and then we'll begin to put them all together. So I hope you're with me right now. If not, don't go any further until you are with me. Thanks for being here today, and enjoy the rest of the day. Bye-bye.